Hey everybody, this is chapter 5, the periodic law chapter, also the chapter all about the periodic table. We have done all the ins and outs of all of the elements, so now it's time to talk about how they are organized and what kinds of amazing things we're going to talk about and see in this chapter concerning your best friend, also known as the periodic table. All right, so first things first. Okay, elements have been known since pretty much the dawn of civilization, and these key components go all the way back to alchemy and all that kind of stuff. And there really wasn't anyone to put them all together until 1869. And his name is Dmitri Ivanovich Mendeleev. He was this Russian scientist that had a really tough upbringing, that was the first person to organize elements into a chart. Okay, so mind you, I want you to really think about it at this point. Okay, this is 1869. There's really only about 70 elements known at this time. So he put them into a chart. He's like, look, these are all the fundamental things in our universe. I might as well see what I can do with them. So he organized them. And when he organized them by increasing atomic mass. And what he found is that there were patterns. And with these patterns, he knew he had to leave blank spaces for undiscovered elements, which was crazy. All right, people were like, you are absolutely cray cray for thinking of this. What do you mean there's more elements? This is modern times. This is 1869. There's no way that there could be more stuff. Like, he was like a laughing stock, and he like bet his bottom dollar. He's like, no, 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 I'm right, I'm right, I'm right. Guess what? He was right, because how many elements are there? There's 118. Okay, 104 that are natural, but nonetheless, there's 118. So there's definitely elements that are missing. Okay, so this is Dmitri Mendeleev. Again, he was a Russian scientist, so you'll see that all of this stuff here and here is all in Russian. But you'll see he had hydrogen, and it has a mass of 1. It has lithium with a mass of 7, beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium, and it has their masses pretty evenly. Okay, so this is pretty comparable to what they have today. This is 9.4 AMUs, and in Russian and in European countries, decimal points are actually commas. Gets very confusing, I know. Especially when my mom is like writing out numbers for checks and stuff, and it like boggles my mind. But you'll see in a couple of locations here, there are question marks. He goes, there has to be something with a mass of 45 that hasn't been discovered yet. And what about these guys? Like, these all have question marks. So there are elements that he's like, there has to be something that is going to go here. They might be discovered after when I'm gone, but these blanks are very important because they're going to establish that there are patterns. And that's what this entire chapter is about patterns. Well, Mendeleev was right, okay? There was definite patterns. And a British guy, Henry Moseley, picked up where he left off. And he said, yeah, this is absolutely correct. However, instead of putting them by increasing atomic mass, we're going to put them by increasing atomic number instead. Okay, so we're going to um, go about and talk about, hydrogen as 1, helium wasn't discovered yet, and then lithium as 3, and then you can leave these nice easy blanks. Beryllium as 4, boron as 5, instead of using numbers like 1, 6, 9, 10, 12, 14, 16, 19. That would be pretty tough. It's much easier 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and what he found is, yes, they were definitely going to um, have these patterns. And he also found that they made groups for their properties. And this was huge because it started to put this magical table together. Okay, one of the big things that this solved was, like I said, the grouping of our elements. So if you take a look at number 19 and number 18, which is our potassium and our argon. All right, so the mass of potassium is 39.1 AMU and argon is 39.95 AMU. Okay, so this one is heavier and this one is lighter. But look who has more atoms. Huh, okay. Argon is also a noble gas. Okay, so if it's a noble gas, it should be with the other gases. Okay, and potassium is a metal. It should be with the metal. So if you picture it on the periodic table, they would be on completely opposite sides. All right, so we had to make sure that you ended up seeing the correct way, which is with atomic number and not mass. All right, and then everything would be lined up with everybody else on the periodic table. Okay, this is really what the foundation is for this chapter, is that there is this thing called periodic law, this periodic repetition of physical and chemical properties as you go through each and every period, and period is the same thing as row. Okay, that's why we have that repetition. We have periods in the day, we have periods on the periodic table. If you want to get all technical, females go through periods, it's repetitious. All right, so you see that we have all of these rows over and over again, and you'll see that all of these columns, all of these groups are going to have different names to them because they have different properties. Okay, we have our alkali metals, alkali earth metals, which we'll talk about in the uh, next video, our lanthanides and actinides, the rest of the transition metals, and we have our noble gases. Okay, so this stuff is really, really important to see these repetitions. Okay, now lots of people tried to make periodic tables, and some of them are crazy. Mendeleev actually started with this flower periodic table here, where he saw this repetition, and we know that we have the S, P, D, and F blocks for our periodic table and electron configurations. The same thing is kind of true here, S, P, D, and F. But I mean, oh, could you imagine how not user-friendly these guys are and trying to go up and down on the period? Oh, no, no, no. It is much, much, much more user-friendly to use what we have. Now, our periodic table isn't perfect. Like, we do see that we have this lanthanide and actinide series down here at the bottom, and that's because it technically belongs right here in between. So it should make this like crazy little bubble here and then go through. We're obviously not going to do that. We're just going to have it located down here. But these guys don't have the same property as these, so we can't put them directly underneath it. So I actually, in class, have one that is the S block, then it is the F, and then it is the D, and then it is the P. But it's so long and it's really not user friendly, that we just stick with our traditional one. All right, so in the next video, we'll take a look at our groups.